Hi, this is Mark. This video is going to be about how to convert a PD patch into a module for Orac, particularly an Organelle one, but the same principles applies. I assume you've already watched my Creating Modules video, and I'm not going to be teaching PD here as well, so there may be some things you need to go and look up. Okay, so we're going to start with the Nori sampler. That's what we're going to use. Now, of course, before you start converting something into a module, I assume that you know what the module does, because you're going to need to know its functionality. Okay, so what we're going to do, we downloaded it, we're going to copy it into the modules folder. The Nori sampler is quite nice. It's just got one sub patch in it, so it's quite easy. When you're creating a module, you should have as minimum as possible in here. Okay, so I'm just going to now name it into what I'm going to have, which is going to be Nori sampler. Okay, next what I'm going to do is, like the previous video, I'm going to take from the defaults, I am going to take the Pure Data file, the module, just so I've got a data point, and I'm going to copy that into the Nori sampler. And I'm going to take a JSON file from one of the other files, just have something to copy, and again put that into the Nori sampler file. Okay, that's the first part. Now we're going to start as we did before by defining the parameters in the definition file. We'll open this up into our editor. For now we don't need this anymore. So we're going to call this the Nori sampler. This is exactly the same as I did in the previous video, so please go and check that. Okay, now I actually know that this has 4 parameters and they're all percentages. The first one is called speed, and I know it is goes from -100 to 100. Stop it complaining. Okay. It also only has 1 page. Okay, the next parameter is called modulation. I'm lazy, so I'll call it that, and I'll call it modulation. And it runs from 0 to 100. Default of 0 seems reasonable. Next one is start point. 0 is reasonable, and the last one is duration. Okay, and duration probably is better to be 100 to make it the full sample. Okay, we saved that. Now we've got to put it onto a page. Again, this is all done in the first video. I'm just replicating the existing UI. You could change it if you want to, but this duration. Okay, that's it. That looks fine to me. Okay, so now that we've done that, we can put that aside for the moment, and we can start Orac. Okay, so Orac starts. We're not interested in the mother thing, so we're not closing these. I'm just minimizing them. Remember, I'm doing this on the Mac just because it's easier for me to do the screen recording, but you can do this also on the Organelle as well. Okay, so now what can happen is we'll switch to module 2, and I'm going to actually load up into module 2. I'm going to load Nori sampler. Okay, so I've loaded that. Bring that up. Okay, the rest I can just get rid of for the moment. Again, minimizing. Okay, so this is Nori sampler. We do as before. We had to change this to Nori sampler. We'll also change the description as well. Sampler. Okay, that's the first part we need to do. Next, what we need to do is actually start going and getting the code. Now, because it's in the same directory, I can do that easily by just asking for the because it can be used as a sub patch. So I can just load that up, and here it is. Okay, so this is actually the Orac sample code. What I do is I'm going to get rid of this main PD file. So what I do is I'm just going to highlight everything and copy it, and I'm actually going to now create a sub patch, which I'm just going to call PD synth, and then paste that code in here. And then I can close that patch. And this is what we're going to work with. And I can get rid of this. Boom, done. Okay. Now we're going to start doing some work. Now I'm going to go through this in different phases. So you're going to see me swap things in and out a bit. If you were doing it, you could probably do most of the things at the same time. But for clarity, I've got to do it in particular things, steps. Okay, so what we're going to start with actually is doing things like the outputs. Okay, so what we're going to do is, first of all, I'm going to convert these rather than to be throws. I'm just going to change these to outlets. And then this means that over on here, what we can do is we can delete these. Again, like last time, I'm going to mix the audio. This is a great time if you were doing this to do to implement monitoring or something like that if you wanted to. But I'm not going to do that because I don't have to. Okay. Okay. So that means that we know that we'll get the audio out. That's a good start. Now, next things. Let's do the knobs. So, okay, so we'll do what we'll do first is up here you can actually see that it just sets up what the screen's going to look like. We don't actually need anything except for, I do want to keep this label here. So I'm going to edit this bit. I'm actually going to come in here. I'm going to copy that. And you'll see that here what happens is there's a load bang and it sets the auxiliary label up. So we're going to change that to read the same thing. Oh, don't need to get rid of the semicolon. That's good. Okay, then I don't need that anymore. You'll see much of the conversion process is just about deleting things, which is always a fun side of it. Okay, next. What we want to do next is look at the knobs. So, now what I'm going to do, I'm just going to delete this. These things part here, you can see, are simply updating the screen. Orac does that all for us, so we don't need this. What it does mean is we have to remember that somewhere else in the patch, they're obviously going to be used. But we can carry on our deletion process and just delete these. Boom. Next, what we can do, this knob 2. Okay, so knob 2 represents the modulation and it goes from 0 to 100. Now, what happens here is knobs usually return 0 to 1. We're returning 0 to 100. So what we need to do is we're going to turn this into our modulation, which is mod-1. And what we're going to do is we're going to divide that by 100. You'll see actually this code is split into 2 parts. Here, this bit is just the screen. The rest of it's actually doing something. So we get rid of this bit. And then what we're doing is we connect this into the previous outlets here. And get rid of those. So basically what we've done is we've just replaced the knob, but we've had to divide it by 100. That's what we've done. So now what we're going to do is we're going to go and look at for the other knobs. Now, the most likely chances they're going to be in the sampler voice. Okay, and there we are. We can see knob 1 up here, so we can deal with that. Now knob 1 is interesting. It actually runs from -100 to 100. Now, this little bit of code here, all this does is basically convert it from 0 to 1 into -1 to 1. So we don't actually need this at all. What we do is we're going to take this into receive and speed +1. And then what we do is we divide that by 100. And because we're already going from also returning -100 to 100, that will be fine. So that's that, that's good. Obviously we still need to go on a hunt for more knobs. And obviously we've got 2 sub-patches here. Now this is the thing you have to be really thorough when you're doing this. You have to look for sub-patches and you have to look for, be very consistent. So we're going to go into here. This one is, here we are. We can see that we've actually got knob 3 and knob 4. And again, what we're going to do is we'll simply edit this patch. Knob 3 is actually called start point, which was non start. Remember, always add the $1 at the end. Then again, it's a percentage, so we divide it by 100. Replace it here. You'll see what I tend to do is do the replacement first, so that I only disconnect the wire after I've actually got everything in place, so that I know where it goes. And knob 4 is the duration, which was the duration, again, -1. And then divide by 100, which I always forget to. Okay, so that's that. That's that patch done. Now, to be consistent, what we should do is go and check any other sub patches. So here's another sub patch. Does it have any knob values on it? No. Because even though we've replaced it in one place, it might be being used in other places. Okay, so that patch is okay. And that patch doesn't have any knob values at all either. No. Okay, so the next thing I'm going to do is I'm going to look at, for these things, like the notes in, the auxiliary in, and the foot switch in. Okay, so there's nothing here. We can see obviously at the top here that we're receiving the notes, so we need to change this to notes in $1. We also saw here, there's nothing about notes. Is there anything in here? No, nothing in here. Is there a varispeed? No, nothing in here. Okay. Record. Yes, we can see the auxiliary is used up here. The foot switch is used here. And what else? Now down here we can actually see that the LED is also set. So that means the little flashy aux LED. So we can do that, that's not a problem. Sending it 1 and 0. We simply can come to that module patch. This is it's the same bit here, so we just put it in here. Bam. We're done. Okay, so that means that we've done the notes, we've done the foot switches, we've done the auxiliary in. Now, the next part that's obviously missing, you'll notice, is the audio input. Now, obviously, we're in the record load sample, so surprise, surprise, here is where we can actually see the auxiliary input, the input coming in. Now, I'm going to actually convert these to inlets because I think it's much tighter. So what I'm going to do is I'm just going to convert these to inlets. Save that. Come here. Now, lost the window. Okay, so now magically our PD audio load summary has inlets. So now we're going to add some inlets to this as well. These are audio inlets, so they need tildes. Okay. Bam. Bam. Okay, so now magically this outer patch also has inlets on it. Okay, so now, are we there yet? Possibly, but we're not really. So what we're going to do is I'm going to now do a little test. So what I'm going to do is I'm going to make the patch reload so that I can actually see if everything's working. And I'm also going to bring up the PD window whilst I do this. So obviously I've saved the module. I'll redo that just in case I forgot. Noise sample, I'm going to go to the ramp sieve and I'm just going to load up the noise sample again. Okay. So here, if I go into module 2, noise sample is loaded, we can actually see the parameters have come on. Okay, now, we'll notice already in the logs that it says it's failed to send the start duration and speed. So if I move speed, we can see indeed it's not working. There's a good reason for this. Now, what you need to understand is that PD can pass parameters into subpatches. So this module PD file, you can actually see has in the top M2, which means it's loaded into module 2. When I come into this subpatch, which is embedded, you'll also see the same M2. And the reason is this is embedded into the same patch, so it's got the same parameters passed. The problem is, if you remember back at the beginning, sampler voice was actually a separate patch, which is why it's not PD sampler voice. So if we go into here, we see there's no M2 here, so we're missing it. So this doesn't get evaluated correctly. So now, if we come into what we need to do is edit the patch and put $1 here. On each patch. And save. Okay, now when we actually open this, you'll now see it says M2. And now, as if by magic, when we twist the speed knob, we don't get the errors. So now we go around twisting more, just checking that. So it's worth always just twisting the knobs just so that you know that the receives are in place. And if the receives are in place, then you've got the naming right, which means you haven't forgotten the -$1 or something like that. So are we there yet? Well, actually, probably this patch would kind of work, but it would have it would have two small problems. The first is if you load it up dynamically, it probably wouldn't quite work properly. We'll come to, and that is because of load bangs. And then the second problem is that if you had two instances, so one in one slot and another in another slot, they would interfere with each other. We're going to tackle the first problem first because that's easy. So what we need to do is we need to look in our patches for load bangs. So there's none in here, no problem. We go into sample voice, we can see one here. For anything that says load bang, we need to change it into receive load bang -$1. That's it. That's the only change you need to make. Now again, we need to be thorough. Does this patch have any? No, this subpatch does not have one. Does this subpatch have any? Yes, there's one. So if you find that a patch doesn't seem to work properly when you initially load it up, probably it's a load bang issue. Okay, carrying on. We need to close this voice, close this voice. Is there a load bang here? Ah, yes, guess what? There's another load bang over here. Okay, so we've done all our sub-patches now. Everything should be good. But now we have to get on to our second problem, which I mentioned, which is that what would happen is this patch, if I loaded it into M4 as well, then M2, if I loaded two Norrie samplers into Orac, they would interfere with each other. And the reason actually can be seen quite clearly. Unfortunately, Pure Data has the sends and receives and all the namings in what's called a global namespace. In other words, they're shared across patches. Now, this is the whole reason that Orac uses this $1 syntax, because it basically goes around adding $1, which is the module slot, to all the variable names so they don't get confused. Okay, so we now need to do something similar. Now, there are two ways of doing this in PD. You can use $0, which is just an instance variable number, but I'm not going to use that because I've got $1 available, and there are certain times you can't use $0. So I'm just going to be consistent. So okay, so what we're going to do is look for sends and receives and anything like tables that uses it, and we're going to do that. So here's the first one. This has to be $1. Now notice if I see a receive here somewhere in this patch, there's going to have to be a send I'm going to have to do. So again, we have to be thorough. Similarly down here, we have a send down here, and again, this has to be $1. Okay, that's it. And you'll see now things start complaining. Okay, that's okay. We're now going to the synth voice. Again, now we're looking for, there's a mod, which was the thing that we've just seen. And we have to look for more. Are there any more sends and receives? Let's look inside sub-patches. Look, there's a receive. Any more? No. Inside here. No, I don't see one. Yeah, sometimes if you do it, you may miss one, and then you'll have to come back and fix it. But okay. Now notice the send and receives have the $0 in front. If the variable name contains $0, you don't need to do anything with it. It's already protected to be its own specific instance. So that's good. We look to be okay here. Now, if we go into here, we can have a look for similar ones. Is there any received? Yep, there's the send for the duration, $1. There's also another one over here, which would be easy to miss. Okay, right. Now we have to get into something that's a little more complex. The little issue here is that this sample is named. So this would be shared across instances as well. Now that's okay. I can come into here, right click, properties, $1. That's okay. That's fine now. And in the table right, I can just use $1. That would seem okay. The problem is, you can kind of see it here. You might be tempted to use $1 here or here. But you'll notice here it's got $1 already. And the reason is because the way that messages work is you can pass in a parameter here called $1. So the problem is you can't just pass in this variable directly in here because it will think it's an input into here. Now the way you actually get around that is not difficult. What you do, I'll show you over here first, is we use something called symbol. So we do symbol $1. This creates us a symbol, and then what we do is we pass this in, and then we can do here. Now we can test this. If we now put a bang actually here, you'll notice this sample hasn't got anything in it at the moment. If I put a one a bang here, you'll see it loads the sample, and that's because it's correctly put the thing in here. If I could just put $1 here, it wouldn't work. Okay, this side is a little more complex because it already has a $1 in it. So what we're going to need to do is we're going to need to pass in an array. So what we're going to do is we're going to pack an integer, a float doesn't make any difference, and a symbol, and that's what we're going to pass into it. And then so the symbol will go into here. Now we're going to do the same trick as we did over here. So we're going to probably duplicate this. Okay. Now we obviously need to get this sent into here. So what I'm going to do is, you could do it another way. I'm just going to add an extra bang up here. It doesn't actually, this doesn't matter to the order. As long as this bang happens before this one, then it'll all work. Okay, so that's $1, that's $1. That looks good. Now what we should do, I think I have done more. But what we should do is we should go and double check. I'm also obviously saving the thing here. We're still getting array issues here. That's probably just because I've not done it here. This presumably, oh bang. Ah, there it is. Okay. Okay, that's that. Again, a quick check that we've not missed anything. I can't see that we've missed anything. I can't see that I've missed anything. And I've been here before, so. Okay. So I think we're actually ready to test. Now, before we test, what we're going to do is we're going to reload the module. Okay, so to test, how can we test? Well, okay, what we can do is, because this is Orac and it's a bit modular, what we can do is we can actually try to record something in from, say, an arpeggiator. So we'll go to the front, I'll switch to punchy, and just do something silly. No, too fast. Always need a bit of reverb. Now, just so I'm not talking over the video, we should now be able to do is we should now be able to play the ARP, record it, and then what I should be able to do is to turn the ARP off, and then obviously it should be able to play via noise. That's if I've not missed anything. And what we can then do is we can check to see whether or not the parameters are doing what they're supposed to be doing. So let's start something. We'll put it in latch mode. Okay. We record. Oh, press the hold to record. LED seems to be working. Okay. Now I thought it hadn't worked, I forgot the speed was 0. So that all appears to be working quite happily. So now we can do some fun things. So obviously what we can do now, which is quite fun, is, so obviously this is fun. But now if I go back to here, we can start using the sequencer as well as the thing. So we could actually punch in a new sequence. And what's going to happen now is the two are going to be layered. So okay, isn't not a good. Okay, I should have thought that through more. But anyway, the point is, we can see the Orac sample's working. We can see everything's okay. Really, that's what I want to show. Obviously, talking, it takes a lot longer than actually just doing it. But hopefully, that's given an indication of what you need to do. It's very similar for all of the patches, really. Really, the things to remember are scaling the knob values correctly, load bangs, looking for sends and receives that are in the global namespace, looking for delays or tables that are in the global namespace. If you forget the last two, as I say, the module will work, but if you load up more than one instance of it, they will interfere with each other. So they can be a bit spurious. I'm not going to show that working here because this gets too complicated to set up, but obviously I've shown you the process. Okay, I hope that helps. I hope some people will now feel happy to convert some modules. Have fun with Orac.